Uh, in today's class, we are going to uh, spend some time to review free fall motion, right? Okay. So if you think that you are confident, okay, and you do not need any further revision on this topic, so we can move on. But I would like to discuss at least two graphs, okay, related to free fall motion. Am I audible?
Yeah.
Okay. So I'm going to discuss the two graphs, right? Okay. So are you able to recall what free fall motion is? Do you know what free fall?
Yeah.
Yeah. So can you please share one or two points related to free fall motion?
Like free fall motion is like the motion under like a uniform gravitational field.
Okay. Okay. Under the influence of gravity, right? The strength of gravity.
Yeah.
Uh, okay. So free fall motion is the motion of an object, right? Under the influence of gravity only. Okay. So what do you think if I drop two objects like drop a feather, let's say a feather and a bowling ball, right? A bowling ball are dropped, right? Dropped, uh, dropped at the same time, at the same time from same position, okay? From from the same position in air, right? So what do you think? Who will reach the ground first?
The bowling ball.
Yeah, so because it has the greater mass and having the less surface area. Okay, okay. So a uh, bowling, sorry, bowling ball will reach the ground first, right? And our second observation would be air resistance has a greater effect on the feather, right? Air resistance has a greater effect on the feather due to its larger surface area. Okay. And what do you think if air resistance is not there, right? Let's assume if these two objects, like feather and bowling ball, right? They both are dropped at the same time from the same position in a vacuum. The same thing is going to happen, right? The same thing is going to happen. This is the same scenario is going to take place. Mm, uh, Control C and Control V. Okay. So the same thing is going to happen where uh, uh, same position in air, not in air,
In a vacuum.
in a vacuum, right? In a vacuum, right? So what do you think? What will happen? Who will reach the ground first?
Uh, Both of them at the same time.
Sorry, they will
Most of
both.
it.
Yeah, so both will reach the ground at the same time and same speed, right? Because there's no air resistance, no air particles are there, right? So there will be no effect on them, right? Okay, so both will reach the ground same time and with same speed. Okay, right? Because there is as no air resistance would be there. Okay, would be there or no effect. Okay, so this is called the free fall, right? This applies to all objects regardless of their masses in a vacuum. Okay, right? So this is called free fall motion. This applies to all objects, right? So what we can conclude that no air resistance and only weight acting on the object if the objects are falling, right? Okay, and the object is accelerating with a constant speed, right? In every second, that is 10 meter per second square. Okay, the constant, it has constant acceleration towards the ground. Got it? So I hope this topic is completed. Again, I have just uh, you know spent some time on free fall motion. Now, what if I draw a graph, a velocity time graph? Okay, so what do you think? What how the graph is going to be? Yes.
I don't.
Okay. So, do you think there is a constant acceleration? Yes.
Mm, not
Constant
for
of
in a
constant
while.
of acceleration. Okay. Remember, there's constant acceleration, and I have this. I have told this thing that every moment there's an increase of the speed, right? That's why there's a 10 meter per second square. That is the constant acceleration of the body. Okay, because there is only one force that is acting on the body. That is the force of gravity, and this is the weight. Is this clear? There is no air resistance. There is no air resistance since the object is moving in a vacuum, right? It is not moving in the presence of air particles. So there is no air resistance. So there would be no different speed. Got it? Are you getting my point? No?
Yeah, 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 sir. Yeah.
All right. So velocity time, if I plot a velocity time graph, right? So I will find that the graph will start and it will be a straight line, right? And this straight diagonal line, what does it show? A constant gradient, right? Okay, constant gradient. That means the gradient of velocity time graph, what does it show? The gradient of velocity time graph,
Acceleration.
acceleration. So if it is constant, so it will be a constant
Acceleration.
acceleration. Clear? Right? And that is 10 meter per second square. Approximately 10 meter per second square. Got it? Any confusion now?
No.
Okay. So furthermore, what if I take any data, right? And every moment, if I take some values here. So let's say this is one, this is going to be two, this is going to be three, okay? And over here, if this is going to be 10, okay? So next, after 1 second, what should be the speed beta? After 1 second.
After one
From one
second,
to from one to two, what should be the speed at this moment, at this point?
20.
20. Now I think you have got this point, right? So there will be the difference of 10. Clear? In each
Yeah,
second, there's
isn't
a
it 9.81?
yeah, it's 9.81. It's 9.81, but approximately in some cases we take 10 meter per second square for the sake of our easiness. Okay, clear?
Yeah.
So now what I'm doing here, if I ask you to find out the distance, how much distance the body has traveled or covered, right? So uh, are you able to find out?
Yeah.
Yeah.
So
So yes, sure. Tell me.
for for which point? Total distance?
Yeah, total distance.
Okay, so you have to find the area under the region.
Yes, we have
So
to find out area under the region. Good.
so it's a triangle, so you have to
Yeah.
do uh
So
half
if I
time.
say this is A1, and if I say this is A2, if I say this is A3, that is area 1, area 2, and area 3, right? So these areas are telling the distance the body has covered. Okay. So area 1 is going to be how much? From 0 to 1. From 0 to 1, this is the base. Okay. And then
The height is 10. So
uh-huh.
10
So
times 1
half,
divided by 2
yeah. So
is
half
5.
times base times height. So the answer would be 5 meter. Can I say this?
Yeah,
Yeah.
yeah.
Similarly, if I say area 2, so how are you going to find out area 2? Hmm. We are going to, split this, right? Can we split? Yeah.
Yeah, to a
We
triangle.
can split this in two regions. Okay. To find out the area 2, we can split this in this way. So area 2 over here, what are you finding? Uh, that the base is 1. Okay, the base is 1. Got it? From 1 to 2, the base is 1, right? So there must be half. Okay, there must be half. Are you getting my point?
Yeah.
And then from 10 to 20, there's a height of
10.
10. Okay, so the base is 1, the height is 10. Okay, got it. And if I say this, what should be the area of this rectangle? So that's going to be 1 times 10. Got it?
10.
1 times 10. Are you getting my point?
Yeah.
No? Are you not getting?
Yeah, I got it. I got it.
Okay, so I have found the area of triangle in this bracket. And after that, I'm going to add that area. So area of the rectangle. So the area of rectangle that I have found here is 10. So I'm adding that area. So finally, I'm going to get 2 ones are 2 and 2 fives are 10. So 5 ones are 5. 5 plus 10 is 15. Is this clear now?
Yeah.
Okay, so what should be the area 3? Now, can you tell me the total value yourself? Area 3, A3.
Yeah. So the base is 1.
The
So you have to
base
first
is
divide it
1.
by 2. Yeah.
Okay.
So the
Mm-hmm.
base is 1. So to
Mm-hmm.
find the area of the rectangle, it's
Mm-hmm.
20 times 1,
Mm-hmm.
which is 20 meters. And then you also have to add triangle, which is, so the height is 10 and the base is 1. So 10 time 1 1 over 2 times 10 times 1, which is 5.
Mm-hmm. Good.
So you have to
And
add both of them, which
yeah.
is 25.
So the total distance the body has covered in 3 seconds, right, is the total distance covered in 3 seconds is 5 plus 15 is 20 and 25 it's 45 meter. Clear?
Yeah.
Okay. So if I ask you to find out, let's say if I continue to, uh, to this graph, right? So I will have the straight line and I can find out another value. So at 4 seconds, it's going to be somehow over here, and the speed is going to be 40. Okay, keeping in mind that the the gradient is constant here. So if I say that I'm going to find out a region, area of this region A4, so that's going to be around mm, 10, uh, then 20, and then that's going to be 30, right? And we are getting this 5 here, 5 plus 30, we'll get 35. Okay. So you can do the calculation the way we have done here, the same way you can do in A4. Okay. So I hope that you got this point. How have I found the area? Okay. Yeah.
Yep.
Okay, so the total distance, now this time the total distance is going to be so 80, right? Clear? In how many
Yep.
seconds? 4 seconds. Clear? Now if I ask you to draw the distance time graph, right? Because we have the total distance at in 1 second, how much the distance is has traveled by the body? 5 meters. Okay. After 2 seconds, the body has covered 15 meter. Okay. And after 3 seconds, the body has covered 25. And after in next second, the body has covered 35 meter, right? Okay. Are you getting my point? So if I'm going to plot distance time graph, okay, can I plot the distance time graph here by taking this data?
Yeah.
So what do you think how the graph is going to be? Is
Uh,
it going to be a straight line, or is it going to be a curve?
a diagonal line.
It's a diagonal line. Do you think they're about
No,
they're
sorry, sorry. It's a curved line.
it's a curve, right? It's a curved line.
Yeah.
Okay. And that's going to be a best fit curve. Okay, kind of a best fit curve. Okay, so if I plot the numbers here, so let's say I am getting this 1, and then I'm getting 2 over here. This is 4, and sorry, 3, and then 4. Okay, so if I have the equal intervals, then I would be able to draw it properly. Okay, so we have to be very vigilant by putting the numbers. Okay, over here I'm going to put 10. Okay, and then I'm going to put 20, and then I'm going to put 30, and then 40, and then I'm going to put 40, oh, sorry, 50. Okay, right? So this is how further we can tell other numbers, and then 60. Okay, so over here in 4 seconds, how many what is the total distance in 4 seconds?
In 4 seconds, it
What is the
is
total distance the body has covered here?
in 4 seconds, right?
Yeah, in total 4 seconds, what is the total distance the body has covered?
80.
80, right? So you got this point here, right? So what I'm going to do is I need more values, okay, so that I can plot 80, okay, right? Are you getting my point? What I'm going to do,
Yeah.
I'm extending this line so that I can put, oh my God. Oh, that's all right. So I'm going to extend this. So here is going to be 70, and here is going to be 80. Okay. Now you can have a better understanding. Okay. Though I'm not plotting on a perfect scale, but for you know for the sake of understanding, we can have. the sketch. Okay. Though it's not a sketch, sketch is taken without data, right? Whenever we have data, we are just, we are plotting it. Okay, we are making it on the graph paper, okay, with a proper scale uh, defined. Okay. All right. So at 1 second, 1 second, at 1 second, in 1 second, the value is 5. Okay. In 1 second, the value is 5, right? So I need to find out the point here. Okay. Are you getting my point? Now in 2 seconds, it's 15, right? And
So
it's
35.
15. But remember, see, what should be the total distance? 5 plus 15 is going to be
20.
20. So I need to mark on 20 at 2. Clear? So that it will tell us that what should be the total distance in 2 seconds. Clear? Right? And
Yeah.
we have to put extra focus on it because there might be the chance of the mistake. Okay. In total 3 seconds, how much distance the body has covered here? 5 plus this
45.
45. So in 3 seconds, it's 45. So I can make it over here. Oh my God, it's going somewhere else. All right, so let me try it. Let's see what shape we are going to get. Okay, so in after 4 seconds, so what should be the total distance? The total
80.
distance is going to be 80, and I'm going to plot it here, some around, yeah. Okay. Now, do you think is this going to be the straight line or is this going to be curve?
Curve.
Yeah, curve. So I'm going to join all the points. Okay. So I have tried to make it perfect, but yes, though we are getting the curve. Okay. Now, what do you think if the body is the gradient is increasing or decreasing?
It's increasing.
Increasing. So distance time graphs, what is it showing? The speed is increasing or decreasing?
Speed's increasing.
Speed is increasing. Okay. So this distance time graph, what is distance moved by the object, right? Increases for 10 meter every second. Okay. Right?
Yeah.
5, 10, and then 10, 10, 10, 10, 10, 10. Okay. So distance, have you got this point? Distance moved by the object increases for 10 meter. Okay, every second. So in every second, we are observing here that the body, the distance moved by the object is increased by 10 meters, right? I hope you have got all things clear now.
Yep.
Okay. So the gradient increases, right? So what we can say uh, from this graph, from this graph, we can say that gradient increases, right? From this graph we can say distance time graph. Uh, since the gradient is increasing, uh, that's why velocity increases. Okay, right? And here constant acceleration is there. Constant acceleration is there. That is approximately 10 meter per second square. So I hope there is no confusion now. Okay, clear? Uh, yes, Hamza,
Clear.
any confusion now, beta?
No.
Okay, so please do copy down these graphs because they are very important as well. Okay. Now let's have a review of terminal velocity. We we started off in the last class with the topic terminal velocity, right? And what should be the exact definition that we can write about the terminal velocity?
Yeah, can you repeat the question?
Yeah, so the maximum, okay, I could write for you. This maximum speed, right? An object reaches, right? And when, when, when does it reach to the maximum speed? When moving, when moving through, when
The air.
moving through a fluid, right? Okay, fluid, air and liquids, both are fluids. Okay, and why? Because reaches to the maximum speed, and that is a constant speed, right? Due to the due to due to which concept? Due to the balance of due to balance forces. Okay, so what we can say, there is no resultant force, right? That means the drag, that is the upward force, drag or air resistance. Can I say air resistance as well?
Yeah.
Okay. And the downward, that is the weight of the object, right? So both become same. The resultant force, sigma, sum of forces, okay, becomes 0. That means if it is 2 Newton, and it is also 2 Newton. So if I take the sum of these 2 Newton minus 2 Newton, so it will give us 0. Is this clear? Is this clear to you
Yeah.
now?
Yeah. Yeah.
All right. So drag and air resistance, you can use any word, okay, over here. If it is flying and it is coming down. So initially drag force is 0, right? When the body is, starts, flowing, or it starts, moving. So initially, what should be the magnitude of the drag force? Initially,
The drag of the object.
yeah, drag on the object. Yes. So if this is the object, right? Okay, and it starts coming down, so the weight is acting on it. Clear? But the drag would be 0. Clear? Drag force would be 0. So this is the case in the initial, time of the motion, right? Okay. So the initially acceleration is going to be 10 meter per second square, right? Okay. So what happens as the body the speed of the body increases? I told you in the last class that as the body, the speed of the body increases, the air resistance starts increasing with the more force, or drag is going to be more. Okay. Are you getting my point? Yeah. Are you able to recall that point or not? Be fair. You
Yeah.
can, you can tell me. Okay.
Yeah.
So
Yeah. So
after some time, the drag is going to be increased. So that drag force increases, right? As the speed increases as speed increases, right? And the weight is going to be, somehow it starts getting decreased. Clear? Okay. So if we take the sum, this is called sigma, right? That means the sum of force. Okay. Right? Are you getting my point? This symbol is sigma. That is the sum. Sum means that you are going to, take the sum. Oh, sorry, you are going to add them. So drag force is acting upward and weight is acting downward. So you are going to subtract the drag from weight. Okay. So that whatever the net force, resultant force that you get, okay, that will be in that direction the object is going to move. right? So since you can see here the weight is greater, right? Then the drag force, that's why the object is moving towards the weight. Clear? I hope this point is clear now. There's no confusion. Okay. So sigma, that is the resultant force or net force, is towards where? Is towards weight. Clear? Right?
What do you
Now
mean towards what?
towards weight. Okay. So if you apply force to the right side with 30 Newton, right? And someone is applying force to the left side, that is 10 Newton. So where does this object move? To the right side, to the left side?
All right.
Right side. So if this weight is greater than the drag, so where will it go?
If the weight towards the weight, yeah, okay.
Towards the weight. Is this clear? So that's how this is how we express that resultant force, whatever the resultant force, that means that is the difference of or the remaining force after after subtracting, take care from the other direction. So whatever the force that is left there, okay, so the motion is going to be in that particular direction, okay, where the resultant force is there, okay.
Yeah.
So acceleration, so over here, what are we finding? That speed increases and drag force increases. So as drag force increases, so weight has become somehow the weight has become decreased, okay, from the initial step. Okay, so this is your first step. This is your second step. So in the second step, the weight has become less than the first step. So what are you going to conclude? The acceleration is decreasing as drag force starts, acting on it, because over here you can see drag force increases, due to which acceleration, acceleration decreases. Clear? And
Yeah.
after that, when the drag, when the drag and drag, the size of the drag force, see, and the weight both becomes equal. So what will happen? This is your third step, okay? If both become same, okay, in this case, what are you observing? The drag.
It terminal velocity.
Yeah, so this is the point where both forces have become, equal. That's why the object starts moving with the same speed, constant speed. Is this clear? So
Yeah.
drag force equals to weight, this in this case, okay? And the acceleration becomes zero. Clear? Got it? And the
Yeah.
object starts moving with constant speed, which is equal to, or we can say that is called terminal velocity. I hope this is clear now. Okay. And
Yeah.
what we can say, if the drag and weight becomes equal, so we can say sum of all forces equal to zero.
Yeah.
Why am I saying that sum of forces equal to zero? That means if the upward force and the downward force are equal in magnitude, so this is going to be the case that I have discussed it here. The 2 Newton upward, 2 Newton downward. So what will you get? The sum of forces. You will get zero answer because 2 Newton
Zero.
minus 2, so that's going to be zero. Clear? I
Yeah.
hope this is now clear to you. That this is how the object reaches to the terminal velocity, right? And remember, uh, we increase the drag force. We increase the drag force by putting large surface area, right? And this is how when parachutist opens the parachute, so the large surface area, due to the large surface area, all surface area increases, the drag force that is acting upward will also be increased. Are you getting my point or not?
Yeah.
Okay, so is this clear now? Is there any confusion?
No.
So this is how the skydivers and other objects, they decelerate and the speed decreases and they reach to the terminal velocity. Okay. Okay, so one thing you need to remember, whenever there is a higher speed, so there will be the higher drag force. Okay. And if there's a greater surface area, so there would be a greater drag. Clear? So two things you need to remember, that uh, higher speed, okay, so greater will be the drag. Clear? Okay, drag force. Second point, higher surface area, higher surface area, greater drag force. Clear? Clear, beta?
Yeah.
All right, so let's talk about the velocity time graph of the, when the object reaches to the terminal velocity. Did I discuss that graph in the last class? Yeah?
No.
No? Haven't I? See?
Oh, sorry. That. Yeah. Yeah.
Yeah, this one. I'm talking about this one. So what is happening here? Yes?
Uh.
Uh, okay, so let me explain it here again. So over here, you are observing the gradient A decreases, right? Gradient decreases. Number 1 point.
That means drag is increasing.
Yeah, so acceleration, what will happen to the acceleration? Acceleration will
Decrease.
also decrease. Clear? And initially, what are you observing here? Um, initially the speed, since it is steeper, right? So initially speed increases and eventually drag increases. Clear? Are you getting my point?
Yeah.
See, since speed increases, drag would also increase.
Increase.
As drag increase, the acceleration decrease. Is this clear? Got it? And when the object reaches to this point over here, you can see the object reaches to the horizontal line. So what we can say? Constant velocity. It reaches to constant velocity, that is a terminal velocity. Is this clear?
Yeah.
Okay. And over here, velocity decreases in this time, right? And deceleration is taking place.
Yeah.
Okay. And this is the second time it reaches to a terminal velocity, right? When the parachute gets opened. Clear?
Yeah.
Okay. So in the next class, we will discuss free fall and terminal velocity difference with respect to graph. Okay.
Okay.